and investigation 5, and this is going to be the last investigation for chapter 5. So on the exam for midterms coming this week, we'll be covering the module 4 and module 5. In here, we're going to talk about roots and behavior of the polynomial functions. So number 1, the function f is defined by f of x equal to x plus 1 times x minus 3 squared. So we are using the algebraic method to find the roots. So anytime when you're looking for the roots for the polynomial, we are using f of x equal to 0. We just set the f of x because the root always happens when y equal to 0. So 0 equal to x plus 1 times x minus 3 squared. And then we're going to set each factor equal to 0. So x plus 1 equal to 0 or x minus 3 equal to 0. And then we are solving for each x. But x minus 3 squared means there are 2 of the x minus 3 times another x minus 3. So we don't need to write the same factor twice. And then subtract 1 both sides. One root is x equal to negative 1. And then add 3 both sides. And another root is 3. So you have a 2 solution for this case. And then quadratic equation, you're always expecting the 2 solution. Okay, but it could be the 2 of the real solution, but it could be the 1 real solution, but has to be kind of repeated. And then you might have imaginary solutions too. What do the roots of the polynomial function represent? That will be the x value, where the output to the function is 0, which means you just need to set the f of x equal to 0 for x. Okay, so which means this is x intercept, so you might have a negative 1 and 0, or you can get to the 3 and 0. Okay, explain why the polynomial function roots occur where one of the factor has a value of the 0. Because when you have a factor form, okay, so let's say if a times b equal to 0, which means a must be 0 or b must be 0, right? Or a and b are 0, right? But if you have a times b equal to c, which is not easy to find it if the c is not equal to 0, okay? It's hard to find what should be your a and what should be your b, right? So that's why we need to actually set that as at least one of the factor equal to 0, and then that's nice, we can choose it. So this is we call the zero product property. D, draw the number line, represent the value of x, and highlight each of the following. So we need to put the number line, and then number line go from the negative infinity to infinity, and then one x value is negative 1, and other values are 3. Okay, so and then that gives us a 3 interval, which is between the negative infinity to the negative 1, and then negative 1 to 3, and then 3 to the infinity. So we have a 3 intervals. So now which interval will be the solutions? So over here, which interval is going to be the looking as above the x-axis or the below the x-axis? So I'm using the test point. So we are looking for the f of x is a positive or negative, which is a y, isn't it? So above x-axis or below x-axis. So I'm going to use the pass point for negative 2 on here. And then which means you plug it in negative 2 into the function, which is negative 2 plus 1 times negative 2 minus 3 squared. So negative 2 plus 1 is a negative 1 times, the square is always positive, right? So 5, negative 5 squared, but it's going to be negative 25, right? So it's a less than 0. So this is most negative. If I use a 0, I get the positive values. If I use a 4, I get the positive values. So in this time, the intervals of the x, which is function average of negatives, only this interval. So it's going to be negative infinity to the negative 1. And then we're going to construct a rough sketch of a graph of f. So since we have a 2, so let me actually the label. So 1, 2, 3, 4, there's a 1. I'll make the little bigger intervals for x's, okay? Because I have enough room. 2, 3, negative 1, 1, 2, 3, 4, Actually, it should be 1, 2, 3, 4 here. Negative 2, 1, 2, 3, 4, negative 3, 1, 2, 3, 4, negative 4. And also the zeros are the negative 1 and then 3. And then also, I want to find the y-intercept to do this. Y-intercept means x is always 0. So when you plug it in 0, which is 0 plus 1, times 0 minus 3 squared is equal to 9. So if I label this as a 1, 2, 3, 4, 5, 6, 7, 8, 9, so this is the place. So we just need to connect it nicely, okay? Because this is a rough sketch, so this and maybe this to go down here to get this. Oh, sorry, it has to be touch. What am I talking about? Because there are two of the 3 has actually the repeated. So it goes back. Okay. All right, let me look at the number 4. Now we're talking about when x approaches the infinity. What about the y's? So you have to actually be careful with the power. So if you have a function has a times the n to the power, x to the power, okay? So n is odd numbers or n is even numbers. So when it's odd numbers, when x approaches to the infinity, and then f of x also goes to infinity. But x goes to negative infinity, and then f of x goes to negative infinity. So you can try with the x cubes and then the x to the 5th. Even power when x is infinity, f of x is going to be infinity. But x approaches to negative infinity, but still f of x goes to positive infinity because square or even power always the x values makes it positive. So number 1, so x increases without bounds, which means it all goes to positive, no matter what this case, okay? But when x goes to negative infinity, it depends on the power function, okay? So f function is the 3rd power, so go to negative infinity. G function is the 5th power, goes to negative infinity. And then the h function is the square, go positive infinity. And then the j function is 8th power, which is a positive infinity. And also, when we take a look at the number 7, so also we can think about this way too. It depends on the leading coefficient you have. So in this time, we need to watch for the leading coefficient. So when your leading coefficient is negative, it makes a difference, okay? So not right here. And then we have to think about the both ways, okay? Oh, this time leading coefficient for the second one is this one, okay? So highest power. So when x approaches the positive negative wave, which goes to the leading term. So in the b, leading term is negative 2x to 4. The leading term is negative x to the cube, okay? And then when x approaches to the infinity, and then h of x goes to negative infinity because x cube is the it goes the opposite direction of the 4x cube. Okay, so which is when you have but the powers of 4, so if it goes to positive infinity, goes to negative infinity, it goes down for both sides, okay? When it's 2x of 4, of course, it goes both of the f of x goes to positive infinity. But c has a negative 7x cubed, which is a cubic function, so opposite direction. So x approaches infinity, g of x must be negative infinity. And then the x goes negative infinity, g of x goes to positive infinity because of negative 7, okay? It's not about 7, but it's a negative. All right, that'll be all for this section. Thank you for listening.